Day 20. Disable preview. Do I? Yeah. Okay, where are we at? Here. Okay. To do. Yeah, that's probably what I want to do now. Yeah, we'll think about these things. Maybe. What do we got in build.bat? Well, we've got this, which is gonna have to run here in the build script. We've also got all this shader compilation going on. Well, so let's run just some of that here at least. So shaders, well, where do they come from? They come from one file right now, so we can just assume that they're coming from the one file. Shader path code for clone.hlsl. So there's the shaders. Now, I mean, I could just construct a string for now. We could also invoke the compiler directly, but I mean, maybe I should just do that and just replicate this in programmatically. Okay, how do you do that again? Well, let's see. So that's in there somewhere. Oh my god. Yeah, confirm. Oh, okay, so I just needed to press confirm. Is there? Okay, there it is. Yep, okay, so you set up some flags, and then you call d3d compile. So there. Yeah. And that's the binary that it returns, and that's the error. Okay. Well, we're definitely gonna have to read a file. What does read entire file return? U8 array. Shader source. Okay, given the source, we can pass that in to d3d compile. And it takes a bunch of flags, yeah. Okay, so the flags that we care about, let's see, what are those? Well, okay, column major we don't care about, these ones we kind of do. I suppose, well, we need to, oh god, we need to include we need to include what, compiler? I think that's it. So build yeah, that works. So now that we have the compiler, we can call this, and we get out a status. That's for, okay, so these are the flags really. Okay, well, we do want debug. Skip validation. No, skip optimization. Well, that we do want. I mean, I suppose it's well, it depends on what kind of build we're doing. But right now we're just doing debug builds, so let's just write for that. Decompile, skip optimizations, warnings, errors, debug, yep. Pack matrices, I don't care. Partial precision, I don't care. Force, VS, software, no opt. No pre-shader, avoid flow control. As in, like, you can't have if statements? Okay. Prefer flow, what? Enable strictness, yeah, enable by I don't care, who cares about that? Optimization level, well, 0, I mean, we're passing in skip optimization, so presumably this doesn't have an effect. Reserved, warnings, errors, resources may alias. Enable unbounded descriptor tables. All resources bound. Debug name for source. Debug name for binary. Okay. Yeah, okay. Sure. Okay, I think these are the flags. There are 2 flags arguments. Flags 2. Compile effect constants. Okay, I don't think we need these. We need the second flag. Defines, includes, source name. Yeah, we gotta make sure that error messages work when we do it this way, but yeah, we'll figure it out. Defines, includes, entry point, yeah, so that we do care about, entry point. Well, we've got 4 of these, PS sprite, PS screen, PS sprite, PS screen. Well, let's compile one of them, VS sprite. Target, that works. That's this. Target, yeah. Entry, that's debug, warnings are errors, debug info, whatever that does. fxc / question mark. Yes, Enable strict mode, okay. Output, yeah, we're not passing in that many flags. Yeah, and this is the output essentially. Well, I mean, there are three outputs. There is the H result. And what is this supposed to mean? Yeah, I'm guessing just SOK is what we are. Well, I mean, at this point, we're doing these H results elsewhere, right? We have an assert for that specifically. That assert. Might as well move it to common. Yeah, well, let's do it this way for now. Comment that out. Just build and run the build. VBlob is a return value effectively. That's ID3D blob, and so is the error message. D11 blob. ID3D blob. Oh, that one. V blob. Error. Yeah. Okay. So does that compile and run? No. Because we're not linking to the D3D compiler. Pragma, it's pragma lib or something. Pragma comment lib D3D compiler, that one. Yeah. Okay, it compiles and runs. Of course, what exactly happens if we mess up our shader code? Let's see, we're compiling which one? HLSL? No, wait, we're compiling Sprite, that one. Okay. Okay, so it assertion failures here. Okay, so that's how we know it failed. If failed, compile result. There we go, we failed. I believe that's what we do here. If failed, then there we go. Then this is approximately how we get. We need to call ID3D10 blob get buffer pointer. Yeah, we're gonna have to define some macros. Here. Might as well move that to common as well, right? Just for, well, actually no, to build. Although, I mean, if common is gonna include Windows.h anyway. Although build kind of defines that. Alright, you know what, let's just do it in both of these, like whatever. That works. Yeah, we don't have this assert. Yeah, well, probably not gonna do it this way, specifically. We do want to output the message. ID 3D 10 blob get buffer size. Does that work? No, ID 3D 10 blob get buffer size. Excuse me. Yeah, I mean, it's literally just LP. Okay, whatever. Well, that is the message. We want to write that right to std out. Where's our right to std out? We don't have right to std out. Interesting. We do have right file though. Okay. Well, right to std out, stir message, and yeah, this one we're probably not gonna check for failure or anything. Just gonna call this. Yeah, that's good enough. std out message. Okay, well, that's the message. Interesting. Yeah, source name. So I'm guessing if we pass source name of some kind, oh, then it actually does work, kind of. Error. Well, I mean, this is the source name is source path. Shader source path. Yeah, there it is. So now it's picking up that error. Because if we fix it, it'll still hang around because it's from the build. Okay. Well, that works. So we have to do something here. What are we gonna do? Just exit? Or assert or something? Yeah. Yeah, that works. So just do that for all these shaders that we have. I mean, for this file we have 4 entry points and 3 points. Yes, right. Yes, right. PS screen. And well, there is one shader source, so we can just read it once. There's one set of flags for all of them. So for and 3-point index. 3-point index is less than array count, and 3 points. 3-point index plus. Just do that. Except that we need to actually, well, str and 3-point is and 3 points and 3-point index, and that's this one, this argument. Well, the target target also changes. Should I just specify the target as opposed to trying to like detect it or whatever? Although, I mean, VS 5 0 whatever, right? Yeah. If starts and 3-point, if it starts with PS, then target, I mean, I guess I can just do it this way, right? Target string starts, if it starts with VS, then VS, otherwise PS. That. Oh my god. Okay, that does it. So it compiled. We're not writing them out anywhere, but they are compiling. Else, well, actually, I mean, we'll just assert here, right? So we don't need an else. Okay, so at this point we can assert, we can assume that we've succeeded. So assuming that we've succeeded, write it out. Write out the binary. Except that, well, right now we have, I mean, we can start there. We can start there. Except that, do we really need to, I mean, what are we doing with the shaders again? Let's see. Ah, right here. Okay, so we are reading them from here with this weird sort of, yeah, in this weird way we are reading them in. Alright, so instead of writing them out, I'm just gonna put those binaries into the asset file, and well, we'll see how well that goes. Now, another thing I wanted to do, make animation that work in asset file. Yeah, I think you can make that work later. For now though, we've got this blob here, and that can that's essentially just an array. Array v I mean shader data. Yeah, it's these things. There we go. Except for error, we just do the blob. Now that data needs to go somewhere. And I suppose for this block, all I need is just an array of yeah, I should probably move this up here actually. Yeah, because binary building is going to be relevant shortly. So U8 array, well, U8 array star pointer, and then like I32 lang capacity. Shaders capacity is like, I don't know, whatever, that works. Shaders pointer is arena, alloc, array, arena, type U8 array, count, shaders capacity. And then we just push that, push shaders, shader data. Okay, well now they're going somewhere. And the syntax highlighting, just amazing. It's doing an amazing job, as always. So when we're writing out these assets, that's what's being generated. I suppose what I want here is something like just U8 array. I mean, we kind of do want the names. So shaders can't just be this. They need to be more than that. And both things need to know. So let's go to common. And just put that here. Yeah, that first class needs to be removed probably. Type def struct shader. I mean, we kind of just need to know which shader it is. Well, I mean, shader ID, and then U8 array data, and that'll be enough. And def enum. Should this be generated? Yeah, we're probably not gonna have that many shaders, so probably not. Probably not. Although if we did have many shaders, then I suppose I would. So it's something like this. VS sprite, VS sprite, VS screen, and then PS screen like that. Although in principle, I suppose it would be easier to, like, it would actually be easier to just generate these. Which means that, well, okay, let's start there. So we've got these entry points, which are enough to uniquely identify a shader. Where is my... and we'll just generate an enum that has those things going. So, where is my... builder. I just call it builder. Builder enum begin. I mean, this should probably be str builder. Yeah, so it's, well, table. So that's easy enough. We just do str builder enum begin. What did I call it? Str builder. It's just that. Str builder. Name of the enum, shader ID. Str builder enum end. Okay, so enum begin, enum end. Well, let's see. Yeah, there it is. Yeah, that seems correct. And we just put these IDs in there. I suppose this is enough, like str builder enum add, str builder, and name is just entry point, like that. And now in this array they go in the same order as in this enum. Okay. So now we should just be able to... we should just be able to write out an array of shaders and just use that enum for indexing into it. Asset add, oh god, add array field. So we want another one of these, and the array field is UA. Well, I mean it's U8 array, which I think we. Well, let's see how well this goes. U8 array. Shaders. And so what is the data name? yeah, the builder, then name, then data, pointer, and then how many. Well, shaders. Well, that's not gonna. Yeah, that's not gonna work actually. Oh yay, because they're different lengths. Yeah, so this is kind of the same as our frames, right? So we need to put the data somewhere. Yeah, so this needs to be reorganized, and however we do the reorganization, the shaders are going to be the same. So it's going to be like struct, u8 data, and it's like data for all shaders, and then u8 array shader the data. It's gonna be something like that. All data. So this is gonna have like many bytes, right? And then shaders is gonna be, there's gonna be as many as there are these IDs. Yeah. And then well, obviously this thing has a pointer in it. That pointer will need to be fixed up on load. But we can just do that, no problem. So I suppose this is like, well, let's see how that even works. So we begin a struct, then we end a struct. The struct name is shaders. Now we add a field called u8 all data. Oh, well, it could just be like a char u8. I mean, whatever. Keep it u8. u8 all data. Except this array field, that's the type. Then how many? Yeah, we want to transfer the data, so we can just have all the shader data be all in one place, if we're gonna make that work. Yeah, well, let's do that then. Somehow. Shader data. Yeah, well, it's almost like it's a shader data, except that yeah, it's kind of a unique thing, well, for now at least. Pointer length is, well, we need to devote some amount, like 50 megabytes, let's say. Shader data, well, capacity, right? I64 length comma capacity, and it's not the length, it's the capacity, that's that much. Shader data pointer is arena alloc array arena type u8 count shader data capacity. so this is the shaders, just the U8 arrays for the shaders. This is shader data. Yeah, we do need both of these things. So we do this array push, but this we want to copy the whole thing, right? It's like we want to push many push array or something like. Is that gonna work? And it's a mem copy, right? So okay, array push array. Let's try it. Shader data, and then no wait, no. We have two shader datas. Call this one all shader data. They're all shader data, and shader data OG. This one's OG. Then we do this array push array thing. And what we kind of want is shader data copied. What we want is that out of it. I mean, I suppose we kind of know everything we need to know already. It's like all shader data pointer plus all shader data length, and then the length is just it's gonna be the same length. Yeah, that. Yeah, and it's specifically the copy that we want to push over. Okay, so now shader data all goes into one array. The array of shaders is pointing into that array. Okay, well, we know we're gonna have to implement this array push array thing. Yeah, so it's that, but instead of setting it, assert array length well, it's like it's length plus value length. It's like something like that. Usually value length is 1. Or even, well, so if array length is 0 and value length is 1, capacity is 1, like say, so this is greater or equal. So that, but then instead of setting it, we do a mem copy. Destination first, so array source, that's the value, size, well, it's value length times size of dereference value pointer. That. Okay, let's see. Okay, that's the first part, is the assert. There's the memcopy is the important part. So memcopy to all shader data pointer from this shader data OG pointer, length, size of, well, size of pointer. So it's, yeah. Okay, this seems correct. Mostly. So it will, okay, it will copy the thing, and then it's the copy that goes in, okay. Okay, all data, well, now we can use all data here, so that the actual data that will be written out to the binary file will be all shader data pointer, and the length of that is all shader data length. Okay, well, let's find out what that does even. Generated 0. Interesting. Oh yeah, because I didn't modify the length. Yeah, we want to do a memcopy, and then we want to do, oh, actually, we want to do a memcopy not here, but here instead. And then we want to do our lang plus equals file lang, that. So memcopy, and then I'll shade that lang, shade that to G lang. Okay, so the first time around, oh my god, that's the wrong thing is being debugged. Okay, all shader data, add to watch 0, whatever, boom, okay, run through that, yep. So now it's written out something, dxc whatever, right? The length is still 0 though. Interesting. Why did the length not get modified? I mean, all shader data length plus equals shader data g length. Well, this length is not 0, clearly. This length is 0. So the second time, what? Did I not recompile? It's the first time. Second. Wait, now it what? Yeah, there it is. It's modified. Oh my god. Just modified again. This didn't change. So okay, this seems correct. Let's see. All right. Then I generated. So okay, that's how many bytes there are. Okay, I'm gonna go take. Hold on. Zoom in. Is this working? Yeah. So I'm gonna go take a toilet break. so that's working. Now the other field that needs to be generated in addition to all data is well, like the pointers and the lengths, like elements, I suppose. Elements. So what's going to be written out to the binary file? Okay, well, okay, so that's interesting actually. What's what we're writing out exactly? All right, so what we're going to write out is not the pointer plus length. We're just going to write out the length. Because that's the offset. Yeah. So this is shaders pointer, shaders length. So in the binary file, we're gonna have an array. Oh, let's run it. Okay, so this array, okay, so it's not U8, it's U8R. Because that's what shaders are. Right, it's a... I mean, there's a capacity there as well. No, it's shaders pointer points to U8 arrays, a bunch of U8 arrays, and that's what this is. Yeah. So now in the binary file, there's 4 arrays where the pointer isn't actually a pointer, it's an offset, and you have to turn it into a pointer by adding the base of whatever all data ends up being. And that should be enough to access the shaders. Let's see. So, well, I mean, it's read entire file. Yeah, it's these things. Yeah, I mean, this kind of has to come from elsewhere. So let's do that first. U8R shader PS, right? Let's do that. And then wherever this thing is being called, okay, U8VSPS, yeah, that here is where it's being called. Okay, so let's just move these things temporarily out here. And just say, yeah, you have to pass them in as arrays. And we just, okay, so for now, we're just going to read them into the arena, yeah. So, shader name is, whatever this was sprite. So arena is now in Scratch. Yeah, this temp memory block needs to be moved out here. Memory Scratch, like that. We're not really gonna be using the arena here at all, so that goes away. We're also not gonna be using the shader name. Shader VS, shader PS. Pull that out. Then do the same thing here with these shader VS PS things. Sprite as a screen. Like that. Okay, well, shader name should be lowercase m. That. Okay, so this shouldn't change anything because it's we're running the same thing from. Okay, apparently not. Apparently something broke somewhere. Interesting. Is it... what if we don't write it out? Okay, now it works. Okay, so something is breaking if we just write out the shaders. Interesting. Is it the data or is it... yeah, something about animations. Okay, well that's wrong, clearly. It's like we're overwriting them. Is there something wrong here? Pointer size of pointer length. Not that I can... I mean, we're already doing it here with Atlas locations, and that's working fine. Interesting. So that works. Oh. So data builder right here, length is that. Okay, we write out the... oh my god. Write out the data. 1150 whatever. We write it out and it doesn't change. The length doesn't change. Excuse me. I mean... oh, wait. Yeah, binary length is 0, yeah. So begin. So there, this is us writing stuff. Right, more stuff, more stuff. Now, length pointer. Wrote more stuff out. Yeah, so the pointers are all like null and stuff. Ooh, okay. No, I'm not seeing anything obviously wrong with this. Obviously it does break right here. First, last, 0. It's like the delimiters just got overwritten. Had to watch. Structed null. Yeah, so Atlas Animations shaders. Oh wait. Okay. Didn't recompile. So that would do it for sure. Okay, so it does work. Okay, so this so far doesn't. It's just doing the same thing it was doing before. Now we're in a position where we can change this. U8 array shader vs is asset data shaders elements. Well, actually that needs to be fixed up. Yeah, let's fix it up. Probably at load time. Just immediately go through everything that needs to be fixed up and fix it. Yeah, so animations, that will change. For 32, whatever, shader ID 0, shader ID is less than shader ID, well, count. Which we don't have count right now, but we will. Shader ID plus U8 array star shader is asset data shaders elements shader ID, and then shader well, plus shader ID, and then shader pointer, we just offset it, right? We offset it by asset data shaders all data, just wherever this is. Wherever the first element of that is, like that. Okay, what's this? U8 star and U8 star. Oh, actually, it's more like this plus cast as U64 shader pointer, because really shader pointer is the offset. Yeah, there we go. That's what it is. Okay. Okay, we need the shader ID count. that enough? Yeah. Autogen. Like, this seems like the kind of thing that should probably be autogen. But let's see if this even works. To begin with, okay. Yeah, so shader VS, this right here. Shader VS is asset data. Shaders elements, not the fixed. Shader ID, and what is this? VS sprite. Okay, that does work. Shader PS is PS sprite. Okay, now we don't need the temp memory block. Well, let's see, doesn't work. It works. Now we don't need the temp memory block. And the same thing can happen here then. So instead of these two things, it's these two, and instead of sprite, it's green. Yeah, so that works. Okay. Okay, we're packing shaders. Which means what? Which means that I don't actually have to keep these around in the data folder. And in build.bat, there it is. We don't need this part. Yeah. Yes, it just works without it. Okay. Let's see. Yeah, that works for me. Yeah, that's in build. We're including the compiler. Yeah. Just change the names, that's fine. Write to stdout, just added that. Name changes. This is shader packing. Array push array. Yeah, new macro here. Yep. So alright, that's fine. Yeah, so far it's this one. Well. Like, to run the game you have to pack the assets, right? And so if you have this file but you don't have the asset file, well, I mean, I guess if you just get the asset file from, well, it doesn't really make sense to commit it then. Although, it probably kind of does. Like, you can still navigate the code if you have this file. And you should probably be able to navigate the code without having to have the asset file. Yeah, that's fine. That's fine. That's fine. That's fine. Okay. So pack shaders. Now let's think about this autogen. This thing. Yeah, this thing seems like we should probably just in-generate it, right? here. Should just have a function that does that for all the fields of, for everything that has that structure, this structure, which animations should have that structure as well. And, well, let's see, if you look at what this is, it's like, well, this is the index, which just goes for as long as, for this size. We just pull out whatever array this happens to be. No, not array, but whatever value this happens to be, which will be some kind of an array. Well, okay, let's try something, at least. Let's try something. It's almost like strip builder begin proc, and the proc is gonna be like fix asset data fix pointers. Static void asset data fix pointers, and yeah, I guess the declaration can just go in here. Asset data fix pointers, and what does it take? It takes asset data a data that and proc. Okay, so begin proc and proc. That works. And then strip builder add code, I guess. And what's the code? Well, the code, well, let's see, how much can we compress it so we don't have to write strings out that long. So it's that. Yeah. So, alright. So it's this line. Except that this right here should be just index and that. Well, in this case it is shader ID count, because we know we have that. Because we've just generated that shader enum here. That. Okay, so this is obviously just the count of things. And this AData shaders elements shader ID should change to index. So index doesn't change, this changes, and this changes. Well, specifically this changes. Dot elements and dot all data don't change. Okay, so there's really two arguments here. Add pointer fix code. Where's my string builder? String builder begin proc fix loop. What are we taking? We're taking string builder and string.decal. String builder format. Builder, I mean it's just decal, right? It's like %.s lit decal space. That. And then builder in add count capacity current name length pointer. Didn't I have indent level somewhere? Oh, it's indent level is actually in the asset data builder. I mean, maybe it should be a part of asset data building then. So instead of, it's going to be asset add proc. There. Well, we don't need to indent here. It's asset. There. current indentation level plus equals 1. There we go. Okay, so this is asset begin proc. Data builder. Oh, wait. No, it is asset end. I mean, isn't that just begin struct? No, well, no, that's begin like top level struct. Yeah, so let's just leave these as is. Begin end, that's fine. And proc is gonna be something else. Yeah, I guess this should be just begin data, right? And end should be end data. And begin proc, well, I guess. I guess just as with data, I can like fix this. Just call it like on load or after load. And just put whatever needs to happen after load in there. Static void asset and proc. Yeah, why not? Asset and proc. And end proc should be one of these as well. Except we're just closing out and reducing this. So let's begin proc, end proc. And this is, again, this is asset, add pointer, fix loop. Data builder. Yeah, and it's gonna format this string pretty much. Str builder format data b str. Then that's the format string. And this shader ID count here is gonna be %d, I guess. Count. I mean, it could also just be a string, but and we know a data. We've specified a data up there, so really it's this. It's element name, right? Percent dot star s. span. There we go. Count, and this is lit element name. Well, just name. And it's the same name everywhere. Name. Yeah, so I32, I guess count string name, like that. And so count here would be what, like shader's length, and name is shaders, just that. Data B. Okay, well, and asset indent first. So indent and then add this loop. Okay, let's not do this. Let's just look at what's being generated. That's what's being generated. Okay. Yeah, so that's fine. Now asset data should probably have two of these. Whatever we generated here. Let's just do that. There's an extra one. Actually, no. There we go. I mean, I guess I could just not include any new lines in here at all. And just do that. Write a one-liner like that. That works. And this doesn't have to be a double. Okay, now let's make sure it works. Compiles. That's a good start. And then we just do asset data after load. Asset data. Just call it. Yeah, it works. Okay, so that part's automated, at least. I mean, as long as we remember to put the pointer fix loop in here, of course. Which, it's not that bad. Although even that part, yeah, well, okay. So I want to somehow be able to do this. So we need to do this, and then afterwards we need to do this. So it's like if we take our asset builder and then we just keep track of all these pointer fix loops that we need. Struct pointer fix. Element name and I32 whatever length. And if we just keep track of those, like struct pointer fix. Okay, pointer fix star pointer fixes pointer I6 whatever length capacity. So these are the pointer fixes that we want to keep track of. And if we just register one of those when doing this, then we can just run a loop over them. Yeah, of course. Okay, so bin is that, str is that, then pointer fixes capacity is that, and data b pointer fixes pointer is arena alloc array array arena type pointer fix and count just whatever the capacity is there. Okay, so we've got that, so we can push into it. And at this point, if we just do rpush what? Well, data b pointer fixes, and the value is pointer fix, and this is a name, which is shaders. It's that, right? Okay, so I think it's shaping up. Name is this shaders. Name and length is what? Shaders length. That. And then for I32 pointer fix index 0 pointer fix index is less than data b pointer fixes length pointer fix index plus plus pointer fix is data b pointer fixes pointer fix index, pull that out, and then just do this. Alright, so this is gonna be pointer fix length, and this is gonna be pointer fix element name. That. Okay. What does this generate? This should be the same thing. It is. Does this work? Yes. Okay, now this can just happen for something else, such as animations. Well, okay, so this works, right? So let me just commit that. Yeah, this is fine. This is fine. Trailing spaces. Trailing spaces. Yeah, this is all fine. That's the new function. That's the, okay. So that's generate pointer fix code for shaders. And now just do the same for animations. Just do that for animations. And then we'll see how to compress it properly. So what changes? Well, this name changes. This doesn't change. This doesn't change. This name changes to animations. And that's it. No, well, I mean, this changes, obviously. So when I'm writing out the animations, so this animation durations, this is what that is. All data is the durations and the type changes. Instead of being first last delimiters, we're just gonna write out the array of animations. Okay, so that needs to change. So animations is this array. We know how many there are, so it's just an array. Frame count is that frame duration. Alright, frame duration. So this is gonna work similar to the other thing, where we have struct float, like, well, F32 star. This is all durations, all animation durations. F32 start pointer, I64, let's say length capacity. So this is all animation durations. Capacity is something. Works. And this is where we want to copy. All animation durations pointer equals frame duration, frame count. Yeah, I mean, I guess that works. I mean, this is just an F32 array, essentially. So yeah, we need an array of animations, but we also need an array of durations. That's all durations we're going to be building out. Arena, alloc, array, arena, F32, and count is all animation durations capacity. That's the count. That works. Okay, this is all animation durations. Frame count, frame duration, that works. Actually, I already kind of have that. Yeah, this is where I build out the delimiters. And that's probably... that's not something that we need to do. So yeah, let's just comment that out real quick. All animation durations. Go back to this. Okay, all animation durations is this. Animation frame count. Okay, so we're not gonna be doing that part here. What are we gonna do though? I mean, so at this point, well, okay. I mean, I guess we can do the assert here that animation frame count is less than or equal to the remaining capacity. Capacity minus all animation durations length. Okay, so this immediately asserts that we have enough space left in that animation durations array then this frame duration milliseconds, instead of allocating it so frame count is already correct. Frame duration milliseconds needs to be an offset, meaning that it's actually this all animation durations length. And then F32 durations storage is all animation durations pointer plus all animation durations length. So storage is here, but this has to be an offset. That's role-playing as a pointer for now, until it gets fixed later after the file gets loaded. Okay, so the frames durations are stored here, except that this is actually kind of a... this is an rpush situation. Yeah, we don't even need that. We're just doing our push here. All animation durations. And what are we pushing? Oh god. Frame duration milliseconds. That's the value, and storage is just all animation durations. So directly just push it in there. And everything else is Atlas, which we're already handling, which is fine. Okay, so this is all animation durations. This is where they're going. Animation is filled in here. We check for that we can fit, which we don't really need to do because we're doing an rpush here, so that forget about that. Okay, fill in the animation and fill in the durations. And now all we gotta do is dump the durations and dump the animations in the same way that we're handling shaders. Okay, so float all data And this is gonna be all animation durations, just like we have all shader data here. Then we have an AU8 array elements, except that it's not an U8 array. It's an animation array. Animation. Yeah. So each element here is a U8 array. Each element here is an animation. Well, that's what the type is called. Really, it's just this float array, right? Like F32, like F32R, like that's really what it is. But I guess animation, I guess this, let's keep it like this. I mean, it's not obvious what an F32 array would mean for an animation, so it makes sense to have another struct, different names. So the shaders becomes animation. Shaders become animations. Pointer animations length, except that well. Yeah, let's make it an array. Struct animation star pointer I32 whatever length equals something. Animations, and in here length is there, file info's length, and this is animations length, and this is animations pointer equals that. So a bunch of errors. Animations pointer. There's another one. Alright. Yeah. So again, build, let's not do that. Let's just see what's generated. Alright. So we generated this array. So animations, all data, and then elements. Yep. And then after load, we are fixing up animations elements int. Okay, there's 3. That's correct. This count is wrong though. I mean, well, unless you wanna say that, oh well, there is such a thing as a null animation. Maybe you don't wanna say that. Or do we? We could. It would just have 0 frames and stuff like that. Maybe it doesn't actually make sense to have a null animation. Maybe I should remove it. And now animations are just going to be asset data animations elements that. Because once the pointers are fixed up, we don't need to do anything else there. Oh yeah, there is no pointer in animations in there. Okay. I mean, we could modify it, but also maybe we shouldn't. Maybe what I should do is actually just say that, you know, we have this F32 all data and an F32 array with elements, and I just go to common, and we have this U8 array, we have an F32 array, just do that and I'll cast it as an animatic. We know it's the same structurally, so just cast it. Okay, well that will be even easier to generate them. Okay, so run that. So up here we have some running. Alright. So cast this as an animation pointer. Like that. Alright. Okay, well this isn't relevant anymore. It's literally mentioned in one place. So far. Well, Atlas locations at least are mentioned in more places than that. But really, we're only ever accessing the pointer, so... just do that. Okay, I don't know if that's gonna... Well, that works. That works. yeah, now it's just to compress them a little bit. So this should obviously be some kind of procedure. Like asset add what add array add an array of things that also point to things. Add like a double array, nested array, dual array, array of arrays, array of arrays, R of R. There. Okay. So it takes that in. Then we want to take we definitely do want to do this begin struct and struct thing. Begin struct and struct and then do this at the end. So name is something that's passed in for sure. Okay, so name is figured out. Length is another thing that's passed in. Element count. That's this. And data length. This is data length. Oh well. Data element count. I mean all data element count. This is like array element. Oh my god. Array element count. Data element count. Yeah. This is array element count. This is data element count. And this needs to, we're gonna have to call the normal function version of this. String name, then void start data. Okay, this is the data. All data pointer. An element size. that's this. Of course, this needs to change. Str name data type. That's this data type right here. So we're gonna have to take an arena as well. Okay, arena data builder. Data type. Void star RL array array pointer. For array element size. So this right here is array pointer and then array element size. That. Okay. And then we can just define a macro version of this, which is like, okay, so we have an arena. Let's go to data builder. We've got a name. We've got a data type. There we go. Array pointer. That can be skipped. Well, actually, all of them can be skipped because it's just, yeah, so array element count can be skipped, and all data is also just pointer length, so data like that, and we define it to be this. And we do arena data builder, then we do str name, then we do data type, that's fine. And then there we go. Now we've got array pointer, array, well, size of array pointer dereferenced. And then we do array length. And then we do the same for data. Asset add r of r. Arena data builder. Name is animations. Data type is F32. Data type is F32. And array is animations, and then data is all animation durations. That. And we'll just do the same for shaders. U8 shaders, all shaders, shader data. That. Okay, well, it seems to be working. Yeah. All right. So if we just look at asset data animations, yeah, alright, so there we go. So all data is 100, 200, 100, 100. Elements 1, 1, 3. Yeah. Yeah, so that's the first one, this is the second one, this is the last one. And then once we run after load, these get fixed up. So now this is pointing here, this is pointing here, this is pointing here. And I got rid of the null animation. Yeah, there's no null animation anymore. So it's generated, such where it's used. Cumulative frame counts also generated. I mean, we do have a null entity, apparently. Should we have a null entity? Like, is that ever relevant? Well, not right now. Where are we even using entity ID? Well, in build, of course. In generated, yeah. Get Atlas ID. Yeah, this doesn't really need to be generated because it's gonna be the same no matter what. Like, we're kind of packing the Atlas around this way of getting the IDs out of it. Sprite has an entity ID. Yeah, come to think of it, we probably don't need, like, unless there is a reason to have it. Let's just not have it. Yeah, probably assume. Well, do I? No. Okay, well, that still works. Okay. Yeah, that is done. Oops. Yeah, we added array of arrays. Remove the nuns. Handling the animations a little differently now. Remove that. Now just adding array of arrays here. Yeah. F32 array, why not? Remove those nuns. Now we've got that. Yeah, that's fine. All of a sudden it has a problem with these names that are in common. And that's not happening anymore. Handle animation packing the same as shader packing. Generated. So when you open this, there are some errors, but if you open like RoarClone alongside of it, and common alongside of that, does it eventually figure it out? Like, it goes to the right place and everything. Yeah, I mean, a lot of it isn't necessary, right? Like, well, Atlas locations, we kind of do want to refer to them. This, not really. Atlas locations, though, yeah, those are, I mean, unless we want to generate those as well, which you could. And just put them into generated rather than common. Although, no, we do refer to Atlas locations in build. What if I reload window? Does it, like, figure it out? No. Interesting. Huh. to refer to them here. Yeah, it would be kind of painful to not do that. Yeah, if it constantly shows like a bunch of errors in the generated file, it's gonna be kind of difficult to, well, now it figured it out. Interesting. So sometimes it can actually handle non-self-contained files, but like only sometimes, not always. Like if you open things in the right order, it handles it. Also, what is this? Dereferencing a null pointer. Can you like, does it understand this sort of thing? If I just assert that it's not null, like here. Well, actually no, I have to assert it here, right? Does it understand this? No? Oh, okay, well, what about if has this? Okay, I'm guessing it's not going to change much, because that pointer isn't null anyway. Silence, Clang tidy, null, pointer, warning. Okay, well, that's gonna be all for today. Thanks, everyone.